Good evening, and welcome to our final lecture of the fall term. Tonight is all about tests. I'm going to be giving you some advice on how to prepare for and write tests and exams, not just for this course and the tests you have coming up, but in general. And I'm going to be going through the practice fallacy test to show you how to write it. I've already shot the fallacy test portion, and I can tell you that it will be much longer than this part. Okay, the first thing you need to know is that preparing for tests starts with the first day of class. The purpose of a test is to test what you've learned, and you've been learning all the way through the course, right? If you've watched the lectures, if you've taken notes, if you've kept up with the readings and the homework, you should be ready for the fallacy test now. Of course, you're still going to study for it because you want to do as well as possible. But if you haven't done those things and you're planning to somehow catch up now, you're placing yourself at a severe disadvantage. Your brain can only learn so fast, which is why we have spread the learning out over a number of months. I realize you're probably watching this a few days before the test, so this particular bit of advice isn't going to be very helpful if you haven't already been following it, but this lecture exists to help you with all your tests in all your courses, not just the fallacy test that you have this week. Now, I know we use words like coursework and workload, but learning isn't supposed to feel like work. Or at least if you approach it like work, it doesn't work as well. You have to put in more effort for less results. Learning is supposed to be fun. Most of the things that we do for fun, watching movies, playing games, involves some kind of learning. If you take up that sort of attitude, learning will be easier and more effective. Try to show an interest in the material. I know you can't choose what you're interested in and not interested in, which is why I talk about cats all the time, but you can affect your attitude towards the course. You can give that Canadian history course a chance, or try to find something interesting in this modes of reasoning thing. What is a modes of reasoning exactly? You may be surprised to learn that human brains are actually very good at learning. If you're surprised, this is probably because human brains are very bad at memorization, and you're connecting learning with memorization in your head. You've probably heard the brain compared to a computer, or even that the brain is a kind of computer. I can tell you, as someone who researches this topic for a living, that this is completely wrong. Your brain has almost nothing in common with a computer. Your brain probably has more in common with a tree or a car engine than a computer. They're different in almost every way. A computer stores data in a particular location and retrieves that data using a kind of index. But your brain doesn't deal in data. What your brain is good at is doing stuff. Walking, talking, playing sports, plucking your nose hairs. If you want to get good at studying and writing tests and at learning in general, you have to learn to work with your brain and not against it. Your brain is not good at storing facts. What it is good at is understanding meaning. Let me explain what I mean. Facts are like isolated bits of information. Meaning is all about connections between things. One kind of connection is narrative, a story. People are good at understanding and remembering stories. Take the story of Jesus in the Bible, for example. If you try to remember the story of Jesus by memorizing a bullet point list of the things that he did, that would probably be pretty hard. But a story has connections and a flow. Every event in the story helps you to remember the other events. In stories, things don't just happen, they happen because of other things. The more connections you can make, the easier it is to remember things. It's sort of like a spider web or a network. Each thread helps to hold up all the other threads. Another kind of meaning or connection that your brain likes and works well with is why and because connections. Let me show you what I mean with this clip from an educational YouTube channel called Crash Course.
Why do we think that water is necessary for life? Why does water on other planets get us so freaking excited? So let's start out by investigating some of the amazing properties of water. In order to do that, we're gonna have to start out with this. The world's most popular molecule, or at least the world's most memorized molecule. We all know about it. Good old H2O. Two hydrogens, one oxygen. The hydrogens each sharing an electron with oxygen in what we call a covalent bond. So as you can see, I've drawn my water molecule in a particular way, and this is actually the way that it appears. It is V-shaped. Because this big ol' oxygen atom is a little bit more greedy for electrons, it has a slight negative charge, whereas this area here with the hydrogen atoms has a slight positive charge. Thanks to this polarity, all water molecules are attracted to one another. So much so that they actually stick together, and these are called hydrogen bonds, and we talked about them last time. But essentially what happens is that the positive pole around those hydrogen atoms bonds to the negative pole around the oxygen atoms of a different water molecule, and so it's a weak bond. But look! They're bonding! Seriously, I cannot overstate the importance of this hydrogen bond. So when your teacher asks you, what's important about water? Start out with the hydrogen bonds, and you should put it in all caps and maybe some sparkles around it. One of the cool properties that results from these hydrogen bonds is a high cohesion for water, which results in high surface tension. Cohesion is the attraction between two like things, like attraction between one molecule of water and another molecule of water. Water has the highest cohesion of any non-metallic liquid, and you can see this if you put some water on some wax paper or some Teflon, or something where the water beads up, like some leaves of plants do it really well. It's quite cool. Since water adheres weakly to the wax paper or to the plant, but strongly to itself, the water molecules are holding those droplets together in a configuration that creates the least amount of surface area. It's this high surface tension that allows some bugs, and even I think one lizard, and also one Jesus, to be able to walk on water. The fact that water is a polar molecule also makes it really good at dissolving things, which we call it's a good solvent then. Scratch that. Water isn't a good solvent. It's an amazing solvent. There are more substances that can be dissolved in water than in any other liquid on Earth. And yes, that includes the strongest acid that we have ever created. These substances that dissolve in water, sugar or salt being ones that we're familiar with, are called hydrophilic. And they are hydrophilic because they are polar. And their polarity is stronger than the cohesive forces of the water. So when you get one of these polar substances in water, it's strong enough that it breaks all the little cohesive forces, all those little hydrogen bonds, and instead of hydrogen bonding to each other, the water will hydrogen bond around these polar substances. Table salt is ionic, and right now it's being separated into ions as the poles of our water molecules interact with it. Okay, you ready? It floats! Yeah, I know you're not surprised by this, but you should be, because everything else, when it's solid, is much more dense than when it's liquid, just like gases are much less dense than liquids are. But that simple characteristic of water, that its solid form floats, is one of the reasons why life on this planet, as we know it, is possible. And why is it that solid water is less dense than liquid water, while everything else is the exact opposite of that? Well, you can thank your hydrogen bonds once again. So at around 32 degrees Fahrenheit, or 0 degrees Celsius if you're a scientist or from a part of the world where things make sense, water molecules start to solidify, and the hydrogen bonds in those water molecules form crystalline structures that space molecules apart more evenly, in turn making frozen water less dense than its liquid form.
Did you see what he did there? The video was about water, but he didn't just list a bunch of facts about water in isolation from one another. He wove them together in something like the story of water. Water is V-shaped, which makes it polar. Because it's polar, it sticks to itself, which is where surface tension comes from. It also sticks to other molecules, which is why it's a good solvent. The water molecules get in between the molecules of the other stuff, sort of splitting them apart. And because it's polar and has this V shape, water expands when it freezes. It does this because the opposite sides attract thing makes it form a regular crystalline structure instead of just, you know, a disorganized pile of molecules. I remember all of that stuff from the first time I watched that video maybe 10 years ago. I remembered it because the information was presented in this network of whys and because. Is the story of water. Good teachers will try to present material this way, but there are things that you can do as well. Basically, the more active and engaged you are, the better and easier you will learn. One way you can do this is by taking notes in lectures. You should always take notes, even in a course like this one, where the lectures are recorded. This is because we understand and remember things better if our brains are actively engaged in processing them. Taking notes involves actually engaging with the material, since you can't just write down everything the instructor says. You need to summarize, you need to pick out the essential points, and you need to put it in your own words. When you put something in your own words, you are engaging with it on the level of meaning, which is what you want to be doing because your brain works well with meaning. Your brain works in terms of meaning. Lecture notes are not supposed to be a record of the lecture, like a transcript. They are a learning and a study aid. They are a sort of tool that works with your memory to reconstruct the lecture after the fact. Not reconstruct the whole lecture, to reconstruct the parts of the lecture that you've decided that you need to remember. I'll explain that more in a moment. There are a number of different note-taking techniques that you can find on the internet and in other places. But the fact that you take notes and you put them in your own words instead of trying to record the lecture verbatim, this part is more important than the specific note-taking technique you might use. Research has shown that most people retain more and understand material better when they take notes using pen and paper rather than a computer. I think this has something to do with the way your brain is more involved in forming and shaping the letters. Maybe there's something to a kind of flow. However, there are advantages to taking notes on a computer, such as being able to easily edit and rearrange the information later. You should just do what works best for you. Now, as I said before, in order to be useful, your notes should not, cannot contain everything that the instructor said in the lecture. They should act more like a map, allowing you to find the information that you need quickly. Organization is key here. One method of organizing your notes is called the Cornell method. Here's an image of it on the screen, but what matters is that you have some sort of an information, but what matters is that you have some sort of an organization that works well for you. You could use circles and arrows or different colored pens, just as long as you know how it works and you're being consistent. Your notes are intended for you and not someone else after all, so it's fine if they only make sense to you. Which reminds me, when you're taking notes, keep in mind that you will be using these notes to review for tests. You can use your own shorthand and abbreviations, which I recommend because that helps you to keep up with what's being said, and it also fits in with the summarizing and paraphrasing. On this slide, I have a list of common abbreviations, but you can use whichever ones they work for you. Your notes are for you, but keep in mind they are also for you possibly months later when you're studying for the test. So make sure when you're taking notes that you will be able to understand them later. If you use an abbreviation for an important technical term or a character, if you're studying a novel, for example, make sure that it will be clear to you what that abbreviation refers to when you come back to it. What does XXM mean? I don't know what XXM means. One very helpful thing you can do to ensure this is to review your notes after the lecture. The same day, later on in the same day, probably in the evening after you get home. Revising your notes can include such things as expanding upon them. For example, adding the definition for a term that you jotted down during the lecture or making it clear what an abbreviation refers to. Uh, Also correcting mistakes, drawing connections, like with circles and arrows, or highlighting important points. Here, let me show you an example. This is a page of notes that I took in a lecture for a science fiction course that I used to teach in. How come I was taking notes on the lecture instead of giving the lecture? Well, the way the course worked is that I was teaching it with another professor, and we split the lectures between us. So half of the lectures I would be listening and taking notes like a student. Anyway, this particular lecture was on Frankenstein, the the novel. The note-taking method that I used is sort of adapted from the Cornell method, at least insofar as it's split into two parts. So the stuff on the left is what I wrote down during the lecture, and the stuff on the right is what I added when I was reviewing the notes. So at the beginning of the lecture, I drew the line down the middle, splitting it in the middle. I also put the name of the lecture at the top and also the date. Those are useful because it helps you to find it more quickly. So anyway, like I said, the stuff on the left is what I wrote during the lecture. This is not a made up example. This is something that I actually did in the class. I did it in part because I knew that I was going to be giving a tutorial where I was going to be talking about note-taking techniques after the lecture. But these are still real notes that I took in real time during a real lecture. Okay? So on the left is the stuff that I wrote during the lecture, and on the right is the stuff that I added later on after the lecture to expand, clarify, or whatever. As you can see, I also did some highlighting. So as you can see here at the top, uh, where I wrote Frankenstein syndrome and what it is, I added later on some examples of it, some movies. Down here, I added like a definition of the term, like creature means something created, so I added a definition. Down here, I added some names. I mentioned Mary Shelley's mother and father, so here I give their names. I expanded, I clarified, I added things that I might have written down in the lecture if I had time, or in some cases, I added things that I thought would be helpful after the fact. Now, some of you are probably saying, wait a minute, I thought this course was going to be on exams, not on how to take notes. Well, remember, I got onto that whole note-taking digression because I was talking to you about how we remember things better if our brains are actively engaged with them, and how you'll have more success with studying if you work with your brain instead of against it.
All right, Brain. You don't like me and I don't like you. But let's just do this and I can get back to killing you with beer. It's a deal.
Your brain is designed to learn in two ways, through practice and through networks of meaning. If what you're learning in a course is skills, then preparing for a test is easy. You practice the skills. For the fallacy test that we have coming up, you practice finding and explaining fallacies. If it's a math course, then you practice math problems. If it's a language course, you practice by speaking and having conversations in the language you're studying. Maybe with a study buddy. Hopefully, your professor will provide you with materials that you need to practice. For example, math problems. If not, well, you can ask them or ask your TA. I've created a list of additional fallacies for you to practice and posted it to eClass. But don't just use that. Do the fallacy homework assignments again. Download a fresh copy without the answers and treat them like they're questions on the test. Use the four-step method for criticizing a fallacy from the week 9 slides. So that's the conclusion of the argument, the name of the fallacy, the definition of the fallacy, and explaining how the argument commits the fallacy by connecting the definition or criteria to the text of the argument. Note that I didn't do this in my answers to the fallacy exercises. I just put in the minimum information you needed to understand the fallacy. You should practice using the criticizing a fallacy steps because you're going to be expected to do that on the test. Put it in point form if you can, because that will make it easier for your tutorial leader to grade. You can also practice on the examples from the slides and in the readings. I know that the slide will usually tell you the name of the fallacy that it's an example of, but you can still practice the other steps of the four-step thing. Another great thing to do is to look for fallacies outside of the course, like in the Find a Fallacy bonus assignment. Fallacies are everywhere. Blogs, social media, online news, and editorials. You wouldn't believe how many bad arguments there are out there. Or maybe you would. Anyway, just remember that for the bonus assignment, it has to be an actual fallacy in an existing text or post, not an example of a fallacy from a textbook or from ChatGPT. So that's how you prepare for our test, and it's not complicated. For courses that are content-based rather than skills-based, you have to get a bit more creative. Sometimes there's stuff that you have to memorize, like formulas or Lewis dot structures. In this case, try to make the process of memorization as active as possible. If you can, use the information instead of just trying to recall it. Don't just try to memorize a formula, do math problems with the formula. You can find stuff like this in your textbook or on the internet, or ask your instructor. Studies show that we remember things better when writing is involved, so copying what you need to remember by hand over and over will be more effective than just reciting it in your head. Sometimes it's useful to collate information. For example, in preparing for the fallacy test, you can make a list of all the fallacies with their definitions and or criteria on the same page for easy reference. This will give you something to refer to when you're writing the fallacy test, but it will also help you to remember the fallacies. Research shows that cramming is not effective. By cramming, I mean trying to memorize everything the night before the test just long enough to write the test the next day. This is going against the way your brain is designed to work. Spread out the studying, pace yourself, and give yourself breaks to refresh your mind. And make sure you get enough sleep. Sleep is very important when it comes to memory. When it comes time to write the test, you want to be in the correct headspace for it. Headspace can make a big difference. You want to warm up your brain by spending the time immediately before the test thinking about what you're going to be saying on it. So, like when you're waiting to be let into the exam room. Once the test begins, time management is crucial. Make sure you read all of the directions before you write anything, and make sure you understand them. I've invigilated many, many tests when I was teaching the in-class version of this course, and every time one or two people would raise their hands and ask me a question, and then I would quietly point to the part of the exam directions where the question was answered. Yes, that happened every time. If the test is long answer or essay type questions, read over all the questions before you start. This is another way of getting your brain into the groove kind of thing. Then calculate how much time you have to answer each question and manage your time accordingly. Try to complete each question in the time that you have allotted yourself. If there are 4 questions and you have an hour, don't spend more than 15 minutes on each question. This is because you don't want to get stuck on a question and spend so much time on it that you have to rush through the last 2 answers. Remember that you don't have to answer the questions in order either. Tackle the easier ones first. If you get stuck on a question, move on and return to it after you finish the others. It's possible that the answer you're looking for will come to you as you answer the other questions. That's not unusual. Some people like to give themselves time at the end of the test to review, to schedule in some time for that. I'm of two minds on this. It's probably not a good idea for something like a multiple choice test. This is because research shows that when it comes to answering this sort of question, like multiple choice or short answer, your first instinct is more likely to be correct than your second guess. For essay questions, on the other hand, yes, it can be useful to read over your answers and make sure that you didn't leave out words or something. You can make little corrections. Sometimes a tiny word can make a difference. Imagine if you wrote effective when you meant to write not effective, or you wrote moral when you meant to write immoral. Then you end up saying the opposite of what you meant to say. Sounds funny, but I've seen it happen. My final point is that you should try to stay as calm and collected as you can, both when you're writing the test and when you're preparing for it. I'm not going to say don't be nervous, because you can't just choose not to be nervous. I understand that, but try to keep a sense of proportion. The fallacy test, for example, is only worth 15% of your final mark. 100 minus 15 is 85. So you could theoretically get 0 on this test and still get an A in the course if you do, perfect on everything else. You could manage a B even without getting perfect on everything else. Because this test is worth 15%, a B is around 12 out of 15, and an F is around 7 out of 15. This means that the difference between a B and an F on this test is only 5% of your final mark. Remember, the only grade that anybody else sees is your final grade in the course. So it's the only one that matters. The difference between doing well and failing this fallacy test is ultimately only 5% of your final mark. You can easily make up that 5% by doing as good a job as you can on the other assignments. And even if you don't, it's only a difference of half a grade. I'm not saying this because I expect you to fail the test. I expect you to pass the test. I'm just trying to explain that you shouldn't worry about it too much. Worrying never helps in any case, but in the case of the fallacy test, there really isn't anything to worry about since even the bad outcome, if you fail the test, is not that bad because it's not going to have a large impact on your final grade. Okay, so that's what I have to say about preparing for and writing tests. What I want to do next is walk you through the practice fallacy test.